So hello students, welcome you all to this YouTube channel. Today I'm back with it another excellent trick to identify ortho-para-directing and meta-directing groups. Alright, so do watch the complete video because I'm sure after watching the video, any question asked from this topic easily you can solve within seconds. Alright, so let's start the video. Now as you can see here, first I have taken a benzene ring. Okay, now let me tell you a very important point. See, the atom which is directly connected to the benzene ring, we will name it as X, and for the X, whichever atom is connected, we will name it as Y. Why? Just for a simple convenience I am naming it. Okay, here also we have a benzene ring, and here the atom which is directly connected to the benzene ring, we refer it as X, and the atom which is bonded to X, we call it as Y. Now here you can see Y is bonded to X with only single bond, and here we have double bond. So remember one thing, this is the trick, this is the base trick what I am telling you. Whenever the Y is connected to X with only single bond, with only single arm, then that type of groups are ortho-para directing group. They are called ortho-para directing. They are ortho-para directing, and whenever Y is bonded to X with double bond, then those groups are called meta directing. They are called meta directing. Alright, now let us apply this concept on few examples. See here, the first example I have taken as phenol. See here, the oxygen atom is directly connected to benzene. What I told, whichever atom is directly connected to benzene, we will name it as X. Am I right? So this will be X. And hydrogen is directly connected to X atom, so this will be your Y. And now you can observe the bond between X and Y. It is single or double? Single bond, right? So it is ortho-para directing group. So it is ortho-para directing group. So ortho-para directing group. Am I right? First question already solved. Now let us move on to the next question. Benzaldehyde. Now the atom which is directly connected to benzene, here it is carbon. It is carbon. So I will take carbon as X. Now to X which is connected, oxygen is connected. See, we have here single bond with hydrogen and double bond with oxygen. In this case we have to give priority for the double bond. Okay, whenever you come across this type of cases, we have to give priority for double bond cases. Now carbon we have named it as X. Why? Because it is directly connected to the benzene ring, and now to carbon oxygen is connected with a double bond. So whenever you come across an atom which is directly connected to the X with double bond, what I told, meta directing. So benzaldehyde in this group, in this atom, or we can name it as meta directing. Meta directing. So it is meta directing. Next, let us move on to the next question. Benzoic acid. Now to benzene, the atom which is directly connected, what I told you, we will name it as X. And here as we can see here, we have one single bond OH and double bond oxygen, right? Now which we will take, which will give preference, oxygen, right? Why? Because it is bonded doubly, we have double bond. Therefore if we name it as Y, then what is the nature of the bond? Double bond or single bond? Double bond, right? So this is also a meta directing group. Shall I write? Meta directing. Meta directing. Now let us move on to the fourth example. We have phenyl acetate. Now see here, for benzene which atom is directly connected? Oxygen. Am I right? Oxygen is directly connected, so we will name it as X. Now to oxygen, carbon is connected. Don't see here oxygen. For oxygen, again don't consider oxygen because we have double bond. First come across this carbon, we have this carbon. Now this carbon will be your Y. Now between X and Y, which is what is the nature of the bond? Single bond. Am I right? Now what I told you, if you come across a compound which has single bond nature between X and Y, which group it is? Ortho-para directing. Am I right? So it is ortho-para directing. Now ultimately I'll come to a very important compound, that is an anilinium ion. Now this is an exceptional case. See, almost all the tricks, especially in chemistry, have one or two exceptions. Now, in this complete shortcut trick video, the only exception is anilinium ion. Now, if you look at the anilinium ion, you can see this is your X. Am I right? This is your X, and you can consider any of the hydrogen atom. This will be your Y. And what I told you, if the nature between X and Y is single bonded, then what will be your answer? Ortho para-directing, right? But as this is an exception, here we will see that the answer is meta-directing. Okay, this is the only exception in your whole trick. So anilinium ion will be your meta-directing. Okay, that's all. Very simple. Again, I'll explain. If the nature of the bond between X and Y is single bond, then it is ortho para-directing. If the nature of the bond between X and Y is double bond, then it is meta-directing. Then any question asked from this topic, you can easily solve, right? So as simple as it is. Hope you like the video. If you like the video, don't forget to hit the like button, share with your friends, as well as hit the subscribe button. Thank you.